Have you ever wondered if we could make Venus our second home? Imagine the possibility of transforming Venus, our neighboring celestial body, often referred to as Earth's sister planet, into a habitable environment for humans. Despite the stark differences like Venus's thick, toxic atmosphere and extreme temperatures, there's an intriguing similarity between Earth and Venus that begs exploration. If this has sparked your curiosity, buckle up for a journey to our neighboring planet, Venus. Before we set foot on Venus, let's understand what terraforming really means. Terraforming, in its simplest terms, is the science of turning other worlds into a home for humans. It's a concept that's been around for decades, and it's inspired countless science fiction stories and films. But it's more than just a sci-fi trope. It's a serious scientific proposal. To fully grasp the concept, let's break it down. The term terraforming is derived from the Latin words terra, meaning earth, and forma, meaning shape. Combined, they give us the essence of terraforming, reshaping a planet to be Earth-like. This reshaping isn't just about aesthetics, though, it's about survival. The goal of terraforming is to modify a planet's atmosphere, temperature, surface topography, and even its ecology to mimic those of Earth. It's about making a planet breathable, livable, and able to sustain human life. Imagine for a moment that we're successful. We've terraformed a planet. What does it look like? Well, that's where the real work comes in. Terraforming isn't just about creating an Earth-like environment, it's about maintaining that environment over time. This would involve introducing a balance of plants and animals to create a self-sustaining ecosystem. It's like playing God on a cosmic scale with the aim of creating a second Earth. Of course, this is no small task. It would require enormous resources, groundbreaking technology, and time, a lot of time. Some estimates suggest it could take thousands, if not millions of years to fully terraform a planet, and that's assuming we have the technology to do it, which we currently do not. But let's not get bogged down in the how just yet. For now, let's focus on the why. Why would we want to terraform another planet? Well, the answer to that is both simple and complex. The simple answer is survival. The complex answer involves issues of overpopulation, resource depletion, and the existential risk of a planetary catastrophe here on Earth. Now that we understand terraforming, why is Venus seen as a potential candidate? Venus, often referred to as Earth's sister planet, shares some striking similarities with our home. Just like Earth, Venus is a rocky planet with a similar size, mass, and composition. Its proximity to the Sun also places it within our solar system's habitable zone, a region where conditions could theoretically support life as we know it. But don't pack your bags just yet. Venus, while comparable to Earth in many ways, presents a host of challenges that make it a less than ideal candidate for human habitation. For starters, Venus boasts an incredibly thick, toxic atmosphere composed primarily of carbon dioxide, with clouds of sulfuric acid that rain down on its surface. And if that doesn't sound inhospitable enough, the planet's surface temperature averages around 864 degrees Fahrenheit, hotter than the surface of Mercury, the closest planet to the Sun. Beyond the extreme temperatures, Venus also has a crushing atmospheric pressure, about 92 times that of Earth, which would feel like being a kilometer below the ocean's surface. And then there's the issue of Venus's day-night cycle. A single day on Venus lasts longer than a Venusian year, meaning if you lived on Venus, you'd celebrate your birthday before finishing breakfast. Despite these challenges, scientists have proposed several imaginative and ambitious methods to terraform Venus. These range from using genetically engineered bacteria to eat up the carbon dioxide and release oxygen, to bombarding the atmosphere with hydrogen to create water, and even deploying massive solar shades to reduce the amount of sunlight reaching the planet's surface. Some proposals even involve adjusting Venus's rotational speed to create a more Earth-like day-night cycle. All these methods sound like something straight out of a science fiction novel. Yet they're being seriously considered by scientists and researchers across the globe. After all, when it comes to exploring the universe and searching for our next cosmic home, we may need to think outside the box and push the boundaries of what's possible. Despite these challenges, scientists have proposed several imaginative and ambitious methods to terraform Venus. From using genetically engineered bacteria to deploying solar shades, the proposals to terraform Venus are as fascinating as they are diverse. Let's delve into these fascinating theories and see how we might turn our sister planet into a second home. First, let's consider the power of life itself. Some scientists have proposed the use of genetically engineered bacteria. These microscopic pioneers could consume carbon dioxide in Venus's atmosphere, reducing the greenhouse effect and lowering temperatures. Over time, they could transform the planet's thick, toxic atmosphere into something more akin to Earth's. But of course, this is no overnight process. We're talking about eons, not decades. Next up, there's the idea of bombarding Venus's atmosphere with hydrogen. This would react with the carbon dioxide to produce water, potentially creating oceans. The sheer volume of hydrogen required makes this a daunting proposition. But remember, we're thinking big here. Then we have the concept of sequestering carbon with magnesium and calcium. Venus's crust contains vast amounts of these elements, which could be used to lock away carbon dioxide in the form of solid carbonates. This is a process that naturally takes place on Earth over millions of years. But on Venus, we'd need to speed things up. What about blocking out some of that relentless Venusian sunlight? Deploying solar shades could reduce the amount of sunlight reaching Venus, thereby cooling the planet. These shades could be enormous structures in space, or a layer of reflective particles in the upper atmosphere. Either way, the result would be a significant drop in temperature. Finally, we come to the idea of adjusting Venus's rotational speed. A day on Venus lasts longer than a year on Earth. By using gravity assists from asteroids or comets, Venus's rotation could be sped up, creating a more Earth-like day and night cycle. It's important to remember that these are not standalone solutions. Any successful terraforming effort would likely involve a combination of these and perhaps other methods not yet imagined. Moreover, these are all colossal undertakings requiring resources and technology beyond our current capabilities. While these proposals are still in the realm of theory and fiction, they offer a glimpse into our potential future as a multi-planet species. As we stand on the brink of a new era in space exploration, the question remains, could we really terraform Venus? The answer is as complex as the task itself. The future of terraforming Venus is a captivating prospect, teeming with challenges and opportunities alike. Firstly, we have to overcome the planet's hostile environment. Venus's thick, toxic atmosphere and extreme temperatures pose significant hurdles. But with the rapid advancements in technology, we're inching closer to solutions. Perhaps genetically engineered bacteria could be used to convert Venus's carbon dioxide-rich atmosphere into breathable air. Or maybe we could bombard the atmosphere with hydrogen to induce a chemical reaction that would lead to the formation of water. Secondly, the sheer cost and resources required for such an endeavor cannot be overlooked. It would require global cooperation and investment on an unprecedented scale. Nevertheless, if successful, the rewards could be monumental. Imagine a second Earth, a new frontier for human civilization. Moreover, succeeding in terraforming Venus could open the doors to transforming other celestial bodies. Mars, for instance, has long been considered a prime candidate for terraforming. The knowledge and experience gained from Venus could prove invaluable in making Mars, and potentially other planets, habitable for humans. Only time will tell if we can transform Venus into a second home for humanity. But isn't it thrilling to imagine the possibilities?